Good evening, everyone, and welcome to this lecture. This is lecture number 3 in wave optics. And in the previous lecture, we were dealing with superposition and interference. I think we remember what do you mean by superposition of waves. Basically, it is just like superposition of forces. If you have more than one force acting at a point, net force is the vector addition of all the forces. Similarly, if there are two or more waves traveling in the same medium, the resultant displacement of any particle is the sum of the displacement produced by the individual waves, and we have seen that it not only looks like vectors, but the displacement also acts like vector. We know that the resultant vector, when you have two vectors A and B inclined at an angle of theta, the resultant is given by a square plus b square plus 2ab cos theta, correct? Here, when you have two waves which are inclined at an angle of phi, the phase difference between them is phi. The resultant amplitude is given by a1 square plus a2 square plus 2a1 a2 cos phi, and the angle between the resultant amplitude and the original amplitude is psi. Tan of psi is what we already know. What next? We had also seen how we can write the resultant wave. We had written the resultant wave in the form of y is equal to a, which is the net amplitude, sine omega t plus xi. Here I probably missed the point, which is an important one. Not missed because I was supposed to do it in interference. Anyway, whenever we are talking about a wave, in many times, in almost all the times, we are not just concerned by its amplitude, the resultant amplitude of two waves. We are also concerned by one more thing, which is known as the intensity of wave. What is the intensity? Intensity, you can think it of as how sharp, or how much energy is falling per unit area, per unit time. Intensity. Now, this intensity of a wave, remember it's wave optics, is directly proportional to its amplitude ka square. So if any wave, sound is a wave, I am producing a sound, I am producing a wave. This wave has an amplitude. This wave also has an intensity. Now the intensity of the wave that I am producing is proportional to amplitude square. Intensity of wave produced by any medium, any thing will be proportional to amplitude square. So both these waves y1 and y2, which were interfering or which were superimposing on each other, they also had their intensities. So the intensities also get added up. Now this is the formula that we had got for the resultant amplitude of the wave. Remember, intensity is proportional to a square. If you now apply a bit of common sense, you can tell me what will be the formula of resultant intensity of the wave. Resultant amplitude, I am calling it as A. Resultant intensity, I will call it as I. What could be the resultant intensity of the wave? Because that is going to just come in interference, because that is how we define interference. If I look at the definition of interference that I had given, the definition said, and I will again quote it, the resultant intensity is minimum, resultant intensity is maximum. So when we talked about interference, the only point we talked about was not the amplitude, it was the intensity of the wave. See, intensity. Intensity is maximum and intensity is minimum. Therefore, it becomes quite logical to talk about the intensity of this wave, which is found by the superposition of two waves. If I call the intensity as I, what will be the intensity of this wave that is produced? Yes. Remember, intensity is proportional to I square. What will be the intensity of the wave that is produced? We gave A in terms of A1 and A2. We will also give I in terms of I1 and I2. Can you tell me what could be the formula for intensity or the resultant intensity of the wave? We know the relation between amplitudes. Can you tell me from that what will be the resultant intensity? Yes. What would be the resultant intensity?
Under root I1 plus I2 plus 2 under root I1, I2 cos pi.
This entire thing is under root or it is not under root? Your formula is correct, but I think you have said it a bit wrongly. What I'm going to do is I'm going to square this equation. If I square this equation on the left hand side, I get amplitude square. And amplitude square is I. So the formula for intensity becomes I will be equal to I1 plus I2 plus 2 times root over I1 I2 cos pi. Do we understand this? This is the resultant formula. This is the formula of the resultant intensity. Resultant intensity of the wave or the disturbance that is produced by the superposition of these two waves is I equal to I1 plus I2 plus 2 times I1 I2 cos phi. I'll give you a minute to note this down. Remember this formula because this is going to be used. I mean, this entire chapter is about these two formulae, the formula for amplitude and the formula for intensity. If you understand these formulae, the chapter is done. There is nothing left more in this chapter to be discussed if you understand this. Have you noted down, everyone?
Yes, sir.
Then we are back to the definition of interference, and we said that interference is again a superposition of two waves which have the same frequency, which have a constant phase difference, and which are traveling in the same direction. Now, one term that we have used is coherent sources. And remember, what do you mean by coherent sources? Coherent sources are those sources of light or sound or any wave which can produce wave of the same frequency with the same or constant phase difference between them. So what are coherent sources? What are coherent sources? Because we might be needing these coherent sources. What are coherent sources? If I want to write coherent sources, what would be the definition of coherent sources? Anyone? Coherent sources are coherent sources are
So
those
teacher, same frequency with the constant phase difference.
with a constant phase difference. That means the phase difference should not change with time, because if it changes with time, something else happens, and that is known as beats. So we'll do that topic as well. Right now, the phase difference has to remain constant. Those sources are known as coherent sources. Coherent sources. Coherent sources are those sources of light, or for that matter, any wave which produce light of the same wavelength. When I say same wavelength, that means same frequency and are in the same phase. They may not be in the same phase. They have a constant phase difference between them. Such sources are known as coherent sources. Now, these coherent sources will come in this chapter. It will also come in the chapter of sound, Doppler effect, and all those places, sound waves. And we will do those waves, sound waves also. I'm doing it in a systematic way. So when the turn comes, we will also do that. Coherent sources will also come in sound waves. Now there's a difference between coherent sources of sound waves and coherent sources of light waves. What is the difference? That is an important point that you must remember. Coherent sources of sound can be produced by two different sources. For sound, it is not a problem if you have one mic here and one mic here. This mic is producing sound. This mic is producing sound. These two can be coherent sources, which are exactly not coming from one, but we will make one mic, we make other mic. These two mics may be coherent sources. Coherent sources of sound are easier to produce, but we have a problem with light. Coherent sources of light cannot be produced from two different sources of light, no matter how same I make them. If I have one tube light and I have one more tube light made from the same material, same process, same thing, same dimension, same everything, still they cannot produce coherent sources. So coherent source of light can only be produced by a single source of light. And that is what you must remember. Coherent sources of light can only be produced, and remember this is only, can only be produced by a single source. By a single source of light. So basically, I need coherent sources. That means I need more than one source. But those more than one source can only be produced by a single source. How are you going to achieve that? And again, whatever I am going to tell you is just for your academic purpose. It may not have any exam implication unless and until someone asks a very specific question, and I'll highlight those points that you must by heart and remember them. So these coherent sources, as I said, coherent sources of light can only be produced by a single source of light. Now, how can you produce coherent source from a single source of light? So if you can see here, this is one source of light, and I've made a small slit, an opening. The slit is going to come in Young's double slit experiment. Then I have made two more slits here, S1 and S2. Now what you see here, from one source, light is going to come and fall on these two sources. Now these two sources, these two small slits that I have created will now behave as coherent sources of light. Now these two coherent sources of light, S1 and S2, as you see, this is Young's double slit experiment, are produced from a single source of light. This diagram we will see many times in this topic. Coherent sources of light can only be produced by a single source of light. There are two methods of producing a coherent source or coherent sources from light from a single source. The first method is known as division of wavefront. You just have to remember this. The second method is known as division of amplitude. In division of wavefront, what happens is what you see. See, there is a single wavefront, this one. The single wavefront is falling on two sources of light. And then I have one wavefront here and one wavefront here. So this wavefront which falls on these two coherent, these two slits, it gets divided and it becomes S1 and S2. So this method is known as division of wavefronts. This method of producing coherent source is known as division of wavefront, and where it is used in all those cases which we are going to study in this chapter. It is used in Young's double slit experiment. You should know this. In Young's double slit experiment, coherent sources are produced by division of wavefront. It is produced in Lloyd's mirror, Fresnel biprism. They are all what should I say, subtopics of Young's double slit experiment. If you don't want to produce coherent sources from slit is nothing but a small opening in a cardboard. You can do it using a Fresnel biprism, or you can do it using a Lloyd's mirror. All these things, all these methods, they produce coherent sources from a single source of light by division of amplitude. Do we understand this? By division of wavefront. Do we understand this? Yes or no? You just have to remember this. The other method is known as division of amplitude. We might not come across this one. Here what happens, beta, how do we divide the amplitude of a wave? If a wave is falling on a surface or on a medium, on a boundary between two medium, it may happen that some of the wave is reflected and some part is refracted. Wave falling, it cannot be 100% reflected and 100% refracted. There is always some part of the wave which is reflected, and there is always some part of the wave which is refracted. Do we understand this? If we produce coherent sources by reflection, partial reflection or partial refraction, partial reflection or partial refraction, those coherent sources are known as coherent sources produced by division of amplitude, because this amplitude of the wave gets divided. Some amplitude goes in the some part of the amplitude. Let us say 30% of amplitude will be taken by the reflected wave, and maybe 70% of the amplitude is taken by the diffracted wave. Do we understand this? It is used. This type of division of amplitude is used in Michelson's interferometer, and if we get time, we will do interference in thin films. In interference in thin films, we see this division of amplitude. That is a topic that hardly comes in the exam. Most of the topic that we are concerned with will come from division of wavefront. Two ways of producing coherent source from a single source of light. For sound, we don't have to do all this, because for sound, I can have one loudspeaker, I can produce a similar loudspeaker, and they can well be coherent sources. Do we understand this?
Yes, sir.
Please note it down. Okay, don't have to note everything down. That was just for you to see. Just write, you don't have to draw the diagram. No one is going to ask you the diagram. But by diagram, what I mean, you should be able to understand that if they give you a diagram where you have slits, when we are using slits, we are producing coherent sources by division of amplitude or division of wavefront. And if when you are using reflection and refraction, we are using division of amplitude. That is what you need to remember if a question comes on. Now remember, if the sources are producing different frequencies or are not having a constant phase difference, such sources are known as non-coherent sources. Do we understand this? So the opposite of coherent sources is a non-coherent source. Do we understand this? Yes or no?
Sir.
Just note them down, because they might come as a single option correct question, multiple choice question, and these are all knowledge based things. If you know them, you know them. If you don't know them, you just don't know them. Okay, there is no physics involved. This is just a knowledge based question. It's like asking who is the president of the United States. You cannot find out from some logic. Okay, I will apply some logic and find out who is the president of the United States. No, you know it or you don't know it. So you know it or you don't know it. Do we understand this? Then remember, two independent sources, two different sources of light cannot produce coherent sources. They are always non-coherent, no matter how you produce them. Coherent sources of light can only be produced by a single source of light. Two methods: division of wavefront, division of amplitude. Now, we have seen a formula for intensity of the resultant wave. We saw the formula for intensity of the resultant wave, and the formula was I1 plus I2 plus 2 times root over I1 I2 cos phi. Now remember, this formula that we have seen, very important point, because I've seen question of this come in a JEE exam. This formula is only valid for coherent sources. The formula that we have written for intensity or amplitude is only valid for a coherent source. If the sources are non-coherent, and I've seen a question come on non-coherent sources, and that is why I'm insisting so much on this topic, because it is hardly covered. For non-coherent sources, what will be the formula of intensity? Again, this is a question of knowing or not knowing. If you know, you know it. don't know, you don't know it. Formula for non-coherent source remains like this. This is the formula of resultant intensity for non-coherent sources. So if a question comes, and I've seen it comes for non-coherent sources, that cos phi wala factor never comes because the phase difference does not remain constant. Please note it down. I'll give you 2 minutes to note it down. Important points. I've seen question on non-coherent sources come, and that is why I have given you this concept of non-coherent sources, which is hardly covered anywhere. Okay, have we noted this down, Bacha?
No, sir.
Just note them down. They are just for your information. And just remember the diagram for that division of wavefront. Wavefront will fall, and then you will have two wavefronts coming out. That is division of wavefront. So they can make a question like this. They will give you three diagrams, and they'll ask you which is division of wavefront and which is division of amplitude. So you must know what division of amplitude, partial reflection, partial refraction should happen. Shall we begin?
So once can you please open previous page?
What do you mean by previous page? Which one?
Previous slide, sir.
I don't know what is the previous slide. I think this one. I don't know. I don't know what has happened in the past. I only know what's going to happen in the future. This one?
Yes, sir.
Don't write this. This is wrong. This is correct. Partial reflection is correct. This is wrong. Got this? I just saw it. I just highlighted the part which you must know. That is correct. This one is also not correct. Misprints happen here and there.
Completed, sir.
So in division of wavefront, one wavefront will fall and you will have two. You can call it mother wavefront, and you can call these two wavefronts daughter wavefronts. Mother wavefront, daughter wavefront. Do we understand this? Mother and daughter.
Yes, sir.
Okay. Now let us come back to the concept of interference. This is a definition that we have already noted. What do you mean by interference of wave? By interference, we mean the superposition of two waves of same frequency, having a constant phase difference, traveling in almost the same direction. So what happens is, at some places you have maximum intensity, at some places you have minimum intensity. This phenomena where you have at some points maximum intensity, at some point minimum intensity, this phenomena is known as interference. Do we understand interference?
Yes, sir.
Now this interference can be of two types. What do you mean by interference being of two types? Now let us go and see the formula for the resultant amplitude or the resultant intensity. The formula of resultant amplitude was under root of a1 square plus a2 square plus 2 times a1 a2 cos phi, where phi was the phase difference between them. Now, this resultant amplitude depends on a1 and a2, obviously. But apart from a1 and a2, it also depends on the value of cos phi. Yes or no? Yes or no?
Yes, sir.
Well done, sir. And that is what we have to understand. If your cos phi is +1, that means maximum possible value cos phi is +1. I hope math students understand this. The maximum value of cos phi is +1. Then we have this general value of this phi that will be equal to 2n pi. We all understand this? N starting from 0. Put n as 0. Angle is 0. Put n as 1. 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. We understand this?
Yes, sir.
NS1, 2 pi, NS2, 4 pi, NS3, 6 pi. We call it even multiples of pi. Everyone understands this?
Yes,
Not
sir.
the odd ones, not the odd ones. Or if I convert this, this is actually the phase difference. Pi was the phase difference. If I convert this phase difference to part difference, the part difference will come. You know the formula of phase difference and part difference. The part difference will come n times lambda. Yes or no? The difference between phase difference and part difference. This is the most important part of this chapter to understand the phase difference and part difference. So if the phase difference between the two waves is 2n pi, or the part difference is n lambda, what will happen? You will have maximum amplitude. Yes or no? Amplitude becomes maximum. And the value of maximum amplitude becomes a1 square plus a2 square plus 2 times a1 a2, that is a1 plus a2 ka whole square. So basically it becomes the addition of the two amplitudes. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Or if I talk in terms of intensity, the maximum intensity becomes root over I1 plus root over I2 ka whole square. Yes or no? Understand this?
Yes,
I've
sir.
converted amplitude into intensity. This type of interference where you have maximum amplitude or you have maximum intensity, it occurs, where does it occur? It occurs where the phase difference is 2n pi or the part difference is n lambda. This type of interference, my dear friends, is known as constructive interference. What is it known as? Constructive interference. Constructive interference. Constructive. Do we understand this?
Yes, sir.
Constructive interference. What will be the other case? One interference, as you can see, is constructive interference.
Destructive interface.
The next type of interference is definitely destructive interference. What do you mean by destructive interference? Anyone? What would you mean by destructive interference? So let us now go back. My resultant amplitude was under root of a1 square plus a2 square. Remember, this is all pure maths. Physics has got nothing to do with this. So it's all trigonometry. Trigonometry is not physics, it is maths. Now let us talk about this one again. Cos phi. The value of cos phi can be +1, that is maximum, but it can also be if the value of cos phi becomes -1. What is the general angle there? General angle for this to happen, you can write it as the odd multiples of pi. So you can write it as 2n minus 1 pi, where n starts from 1. So the first one will be 2 into 1 minus 1 pi, then 3 pi, then 5 pi, then 7, then 9, then 11. Or you can convert this into the part difference delta x. Delta x will be 2n minus 1 lambda by 2. Odd multiples of lambda by 2. You will have minimum intensity. You have minimum amplitude. And no prizes for guessing this one. You will have it as a1 minus a2. Or If I write in terms of minimum intensity, it will be under root of I1 minus under root of I2 the whole square. This type of interference is known as disruptive interference. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this? This is all that we need to understand in this chapter. Constructive interference and destructive interference. Shall we move ahead?
No, sir, 1 second.
Okay, I'll give you time to note this down.
Completed, sir.
Okay, we need to wait for everyone. This is democracy.
Done, sir.
Everyone, sir? Okay, now we can do a special case, and this special case has come many times in many exams. So the special case goes like this. If A1 is equal to A2, both are same. Let me call this as A0. A1 and A2 are same. So both the amplitudes of both the waves are same, A0. What will be the value of A max? And you can understand that this
2A.
is equal to 2A0. 2 times amplitude you will get. What will be the value of I max in terms of I0? Huh?
2 I not, sir.
4I, sir.
Think,
4I, sir.
think. It is proportional to A square beta. So 2 square beta 4. Okay. Let us move our attention to the other gentleman here. Tung. If A1 equals A2 is equal to A0 here, what will be your minimum intensity? Minimum amplitude, it will be 0. And what will be your minimum intensity? It will be 0. So you will have very sharp interference. We call it very sharp interference. So wherever you have destructive interference, it will be completely dark. If I talk in terms of brightness, it will be completely dark. And wherever you have constructive interference, it will be bright as sunlight. That type of interference is what we are looking at. Very sharp interference, we call it. Dark is almost dark and bright is almost bright. Therefore, to have good interference, we say the amplitudes must be very close to each other. If the amplitudes are almost similar, you will get very nice interference. Dark will be almost dark and bright will be almost bright. Do you understand this, or this is gone above it saying bye bye? Bye. I'm going. Huh? You understand this?
Yes, sir.
Okay. Now, shall we move ahead? Everyone noted this down?
Yes, sir.
Okay. Now, many a times we have seen this thing coming when the amplitudes are same. So we can write a shortcut formula, resultant intensity, and we might be using this formula many a time. resultant intensity for identical waves. More or less ask for intensity for identical waves. So this is how I write it. So if I remember, the formula for intensity was I1 plus I2 plus 2 times root over I1 I2 cos phi. Now if I have identical waves, that means I1 will be equal to I2 will be equal to I0. Here what I am trying to do is trying to devise a general formula. I have given you what is the maximum intensity, 4 times I0. I have given you what is the minimum intensity, that is 0. Now I'm trying to give you a general formula, which formula can come many times in many exams. It has come. So that is why I'm getting you a general formula. If I1 and I2 are equal to I0, and I will not show it to you how it comes, the resultant intensity I can be written as, and that is your homework, how it is done. It will come as 4 times I0 cos square phi by 2. It has got nothing to do with physics. It is all a mathematical calculation and conversion from cos phi to cos phi by 2. I will not go into the details of this. I will just write it as it is. This is the formula that you must remember for identical waves. Now, if you put phi as 0, you will get 4I0. If you put phi as odd multiples of pi, destructive interference, you will get it as 0. Do we understand this?
Yeah, sure.
Pakka?
Yeah, sure.
Okay. Now, sometimes they ask you the ratio of maximum and minimum intensity. So it's time that we note this down. Ratio of I max and I min. Ratio of I max and I min if the waves are not equal. So how do I get the ratio of I max and I min? And I've seen a lot of questions come on this, so please note it down. Right now it may look very simple, but remember, if you can remember it, you should be able to do the question faster than your competitors. So it will be root over I1 plus root over I2 whole square divided by root over I1 minus root over I2 whole square. This is one way of remembering it, or you can remember it as A1 plus A2 whole square divided by A1 minus A2 the whole square. I've seen this type of question come many times in exam, and that is the only reason that I am giving you this shortcuts. Give you 1 minute to note it down.
Done, sir.
Okay. Everyone has done this?
Yes, sir.
Okay. So let me give you a problem based on this, and I hope that you should be able to do it. Remember, problem that is going to come in a JEE may not be just Young's double slit experiment. It can be anything related to interference and superposition. So here is the problem that comes to you, and I hope that you can give me the answer for this one. These are the type of problem we expect in the exam. These are the type of problem that might trouble you in the exam. If two waves represented by y1 is 4 sine omega t and y2 is 3 sine omega t plus pi by 3 interfere at a point, find the amplitude of the resultant wave. I'll give you 2 minutes to do this. Yes, but anyone with an answer?
Route 37, sir.
Route 37, sir. I have an answer. Well done, beta. What about the others? Do we have an answer from others as well? You have to find out the result and amplitude. And what you need to do? Result and amplitude is nothing but under root of a1 square plus a2 square plus 2 times a1 a2 cos of phi, where phi is the phase difference between the two waves. I just need to put the values, get the answer, and stay happy. So it will be root over. What is the value of a1? Tell me. What is the value of a1? A1 is 4. So it is 4 square. My a2 is 3. 4 square plus 3 square plus 2 times 4 into 3 multiplied by what is the value of my phi? Phase difference? It is pi by 3. Yes,
5 by
also?
3.
So cos of pi by 3 I think is half. You just add, multiply, divide, whatever it is, and you get your answer. Hey, everyone got this? Yes or no? And I
Yes,
have
sir.
said to everyone that we got this.
Sir.
Yes, sir. Then I'll give you a minute to note this down because the next question is coming up, and these are the questions that are coming, and this is the question taken from your previous exams. So best of luck. Remember, every question is simple. The first thought that should come into your mind is that the question is simple. Let's see who can do this. Two beams of light having intensities I and 4i, so they are not same, intensities are not same, remember, are interfering to produce a fringe pattern. What is this fringe pattern? Don't worry, some technical word that we will understand as we go on. The phase difference between them is pi by 2 at point A. So the phase difference is different at different points. At point A, the phase difference is pi by 2, and at point B, the phase difference is 2 pi. Find out the difference between the intensities at A and B. So you have to find out the intensities at A, intensities at B, and then tell me the difference in intensity. Your time starts now. I see a lot of chit chatting in the class. I hope it is all in good spirits and in tune with what we are doing in the class. Remember, time is a luxury beta that we don't have. The most precious thing that we have is time. Everything else can wait. Everything else has to be done in its proper time. Right now, we are studying physics. These are questions that are going to come in your exams. So I hope that we should be trying to solve the question, get the answer, and stay happy.
Sir, at point A, intensity is 5i.
Beta, I want the final answer. The final answer is the difference between the result and intensity. When this question comes in the JEE, they will give you all the options. They will give you 5i, 6i, 4i, 1i, whatever. So to give me the final answer. Y is correct, but that is not the answer.
So difference between them is 4i.
No, yes, that is correct. The difference between the intensities is 4i. Well done. What about the others? In the class, that is correct.
We got it, sir. 4, I.
Okay, how are we supposed to do this? We first write the formula of intensity. Intensity is I1 plus I2 plus 2 times root over I1 into root over I2 into cos of phi. Yes or no? First thing is I find the intensity at point A. To find the intensity at point A, I must know the value of the phase difference and I must know what are the value of I1 and I2. The value of I1 is I. The value of I2 is 4i. So I plus 4i plus 2 times root over I into 4i into cos of pi by 2. Cos of pi by 2 is 0. So this terms cancels. The answer is 5i for the first case. You can find the intensity at point B. Intensity at point B will be I plus 4i plus 2 times root over I1, I2 into cos of, how much is this? 2 pi. What is the cos of 2 pi? It is plus 1. Yes or no? Oh, I've written I1 and I2. I should have written I into 4i. Sorry. I into 4i. Cos of 2 pi is 1. I into 4i is 4i square. 4i square ka root is 2i. 2 into 2 is 4. So the final answer would be 9i for this one. Yes or no?
Yes, sir.
But we don't have to find IA and IB. I have to find the difference. So IB minus IA will be 4i. That is the answer that we were looking at. Do we understand this? Yes or no?
Yes, sir.
Well done. If you got this, then I have this one, and this one will require something that you might know or you might not know. So try it, and I will give it in the form of a question. Everybody noted this down?
Yes, sir.
Okay. This is a question again taken from your previous exams. And this question talks about the slit widths. Slit widths. Now, what is the relation between the slit width? Now, it is very easy to understand that if you have a slit which is very small, and if you have a slit which is very big, the intensity that is produced is directly proportional to the slit width. So you can note this point. Intensity of the wave is directly proportional to slit width W, and it is directly proportional to amplitude square. This is a very important result that you must remember because many questions have come on this result. Intensity is proportional to the slit width, which is directly proportional to the amplitude square. Having given this information, now I hope that you can give me an answer for this question. I will wait for 2 minutes for you to solve it. Yes, do we have an answer?
We are doing, sir.
Okay. I can see a lot of teamwork. That's good. Yes.
Sir, 25 by 16.
Ma? 5 by 16? It is 4 by 16. One part is correct. 1:4. Must be somewhere. You missed something. See, this question is all about maths. Physics just plays a very small part here, bacha. Shall I do it? Find the ratio of minimum to maximum. So minimum should be on the numerator and maximum must be on the denominator. So 25 by 16. Minimum cannot be 25 and maximum cannot be 16. So what I'll do since time has run out, I'll give you this one as a
We
homework.
got it, sir.
You got it, sir? Well
Yes.
done, sir. So I will just start off the question and probably you can finish it. W1 by W2 is now equal to I1 by I2. We understand this step, yes or no? That will be equal to A1 square by A2 square. And that is given as 1 by 9. From here I can get the ratio of A1 by A2. A1 by A2 is 1 by 3. That is the first step that you should have done. I hope you have done this step, yes or no? From this step by maths, you had to get to that step. I minimum by I maximum. What will be the formula for I min by I max? I min by I max is A1 minus A2 whole square divided by A1 plus A2 the whole square. I will not solve it for you. So basically what you do is you either get A1 in terms of A2, which is simpler, or A2 in terms of A1. Put the values of A1 and A2 in this equation and get the value of I min by I max. Can you do that? Yes or no?
Yes, sure.
If you can do that, that is great. Because as I can see from a glance that A2 is basically 3 times A1. And if I straight away put this value in the equations, I will get this as 4 divided by 16. So the answer would come as 1 divided by 4. Everyone got this? How I've done this? Yes or no? Well then, that brings us to the end of this class. We have been moving quite slowly as compared to the NEET section, because NEET section probably I will be able to complete this maybe in the next class. But here we have still not started with YDSE. Anyways, I hope we can pace up and we will continue with this topic in the next class on Monday. So take care. Have a nice day.
My sir.
God bless you all.
Sir. Bye.
Bye.
Excuse me, sir.
Excuse